This video explains about quadratic functions, graph, and their properties. The square function h of x equal to x squared is a quadratic function. The graph of that looks like a parabola here. These type of functions are helpful in various fields like reflecting telescopes. They use parabolic shaped mirrors. Automobile headlights use parabolic reflectors. Satellite dish antennas use parabolic shapes. Solar furnaces are shaped like parabolas. And we have parabolic microphones, which are mainly used in sporting events. The definition of a quadratic function is f of x or y equal to ax squared plus bx plus c. And if we are trying to solve, or if we are trying to find where it crosses the x-axis, we can equate that to 0. Y is 0. So ax squared plus bx plus c equal to 0. So we have solving quadratic equation ax squared plus bx plus c equal to 0 using the formula x equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. This is the formula we often use in algebra too. We can find the solution to this graph, or we can find where it crosses the x-axis using our graphing calculator. If we want to find where it crosses the x-axis, that is, if we want to find what are the zeros of this function, we can use the zero key in our graphing calculator. That is, if we select second calc, after graphing it, if we select second calc, we can find number 2 as the 0. If we press 0 and try to find where we want to find this 0, whether it is in the left extreme or the right extreme, you can easily find what those x-intercepts are. If you are trying to find what is the y-intercept, the y-intercept is can be obtained by substituting x equal to 0. So we can make use of the value key that is using the same second calc. Number 1 is value. You substitute x equal to 0, whatever value you get for y will be the y-intercept. So in this diagram, we can easily find the x-intercept. There are two x-intercepts using the 0 process. And you have only one y-intercept because it crosses the y-axis at only one point. So that will be when x equal to 0. If we are trying to find the x-intercept and y-intercept for negative x squared plus 5x plus 3 equal to 4, we can use two methods, like the method what we used earlier by taking this as negative x squared plus 5x plus 3 minus 4 equal to 0, which is negative x squared plus 5x minus 1 equal to 0. We can use the same process like the previous one, or else we can take the two expressions, the left hand side as one function, right hand side as one function, y1 and y2, and we can find where it crosses the x-axis, in which case we can find the intersection of the two curves. The intersection of the two curves will be the solution to this. So x equal to 0.2087 and the other intersection is at 4.7913. So those will be the solution to the equation, or the point where the two values are intersecting. So when you're using a calculator, you can substitute that, and you can make use of number 5, which is the intersection, and you can find where it intersects by taking the whole function as in our previous case. Or we can take the two expressions separately and get the results. In both the cases, you'll get the same answer. Sometimes we can rewrite the quadratic equation, the quadratic function, in the vertex form. The vertex form is nothing but a times x minus h the whole square plus k. We can rewrite in this form then hk will be the vertex. The original one, f of x equal to ax squared plus bx plus c, is called the standard form. The second one, f of x equal to a times x minus h the whole squared plus k, is called the vertex form. The vertex form can be used to get the vertex for this function, and it can be obtained using the process of completing the square. For example, if I have negative 3x squared plus 6x minus 1, I can complete the square by pulling that negative 3 outside. So inside I have to add 1 because I would like to make this as a perfect square, x minus 1 the whole squared. When I'm adding 1 inside, I have to subtract that 1. So the whole thing becomes positive 2. And hence hk will be 1, 2, and that 1, 2 will be a vertex. The vertex can be found using the graphing calculator also. Let us graph this function. And the highest point, the maximum point, is our vertex. So in order to find this, maybe you can use the option to find the maximum or the minimum. Here in this case, it is the maximum. The maximum point is 1, 2. When you have this vertex form, you'll have positive hk as the vertex. Sometimes it will be the minimum if it is the parabola opens upward. If it opens downward, then that will be the maximum. So you have to either find the minimum value or the maximum value of the function. The vertical line passing through that vertex will be the axis. So if we have a function f of x equal to say x squared minus 8x plus 12, we can enter that in a graphing calculator, or we can get that as a vertex form, x minus h the whole squared minus 4, by making that as a perfect square. So in this case, we are adding a 4 squared, and you have to subtract a 4 squared. Negative 4 squared plus 12 becomes negative 4, and that's how we got x minus 4 the whole squared minus 4. So 4, negative 4 will be the vertex. Earlier, we have used a graphing calculator to draw the graph, and the minimum value of this graph, the minimum, which is at x equal to 4 and negative 4, will be the vertex. Or we can also find the vertex form instead of using the perfect square method. Instead of rewriting in the vertex form, we can draw these graphs and find what these vertex are using the minimum or the maximum. In order to find the intercepts, we always use the zero process in our graphing calculator and get the result. So we can try these problems for extra practice. This video helped us to understand what a quadratic function is, how to get the standard form, what is the vertex form, using the vertex form, how to get the vertex hk by using a graphing calculator, minimum value or the maximum value, and we also know how to find the intercept of the graph by taking the zero process in a graphing calculator. Hope this video was helpful. Thank you for listening, and thank you for watching.